Hello friends, I'm Samir and I welcome you all to your own YouTube channel Aryabhatta. Friends, today our topic of discussion is solving a system of linear equations by matrix method. So here in this video we are going to learn how to use the matrix method to solve a system of linear equations. So before moving to solve a system of linear equations, first of all let's know what it means by system of linear equations. So a system of linear equations means more than one equations combined together, of which we have to find a common solution. So if more than one linear equations are taken together to get a common solution of them, then it is called system of linear equations. And friends, linear equations means the equations where the variables, how many variables doesn't matter, but all the variables, power or degree or index should be only 1. If there is a variable in that equation in any term, then the power of that variable should be 1, not greater than 1 or not less than 1. Okay friends, so as we are habituated or to solve or to use matrix of order 3 or order 2, so we'll take 2 equation system or 3 equation system to solve. So in general, let's take 3 linear equation system to solve. Okay, so suppose we have the following system of equations. We have taken 3 linear equations. So 3 linear equations having 3 variables x, y, z in them, and the power of x, y, z all are 1. So we have a bunch of 3 equations, linear equations together. It is called system of linear equations to solve. And the equations are like this: a1x plus b1y plus c1z is equals to d1, a2x plus b2y plus c2z is equals to d2, a3x plus b3y plus c3z is equals to d3. Okay friends, here a1, b1, c1, these 3, and a2, b2, c2, and a3, b3, c3, all these 9 symbols represents the real coefficients of the variables x, y, z respectively. And the right side constants d1, d2, d3, they are pure constants without any variable attached to them. Okay, so as we are to solve it by matrix method, so first of all let's derive some matrix out of this system, and let's represent this system in terms of a single matrix equations, because solving these 3 equations together will be quite hectic. So if we can convert it to one matrix equation, then we can solve it easily. Only one equation will be very easy for us to solve. So let's first of all divide this whole system into 3 matrices. First of all, the body matrix, let's name it the matrix A. Body matrix contains all the coefficients of the variables x, y, z in the 3 equations according to their serial order. Okay friends, this first row a1, b1, c1 are the coefficients of the first equation, second row for second equations, and third equations are for third constants here in the equations. Then the matrix X is the variable matrix. It is a column matrix of all the variables in the system, and those are x, y, and z. And at the last, matrix B is also a column matrix. It contains all the right side pure constants, the constants without any variable coefficients, d1, d2, d3. So in that way we have 3 equations, three matrices, A, X, and B. So if you multiply A with X, matrix A with matrix X, then we'll get the matrix B as the result. So the whole system now, the system 1, can be represented in the form of matrix form as A into X is equals to B. Now besides solving this system 1, which contains 3 equations, we will focus on solving system 2, which is the same system but in matrix form, and it is a single equation of matrices. So let's now solve and focus on the matrix or the system 2, which is a matrix equation. Now before solving this system 2, let us first discuss different categories of equations. Now first category is homogeneous equation, a system of equations. This system 2 is called, this system 2 which is Ax is equals to b, it is called homogeneous system of equation if the right side matrix b is a zero matrix. That means if all the constants d1, d2, d3, pure constants d1, d2, d3 will be all 0 together, then this system is called homogeneous system. And it is called non-homogeneous system of equations when this matrix B, this right side matrix B is not 0. That means not all the elements d1, d2, d3 are together 0 at a time. Okay friends, so homogeneous and non-homogeneous. Now let's discuss the formula to solve this system 2, A into X is equals to B in form of a theorem. The system of the equation 1 has a unique solution if and only if the determinant of the matrix is not 0. That means the matrix A is non-singular, and the solution of the matrix X, the solution of the matrix is the value of the variables x, y, z which are contained in the matrix X. So X is our solution matrix. So the solution matrix X, its formula will be adjoint of A multiplied with matrix B and divided by the determinant of A. So the solution of this system Ax is equals to B contains two parts. That is, first of all we have to find out the adjoint of A, then we have to multiply it with the matrix B from the right side, and with that whole product we have to multiply 1 by the determinant of A, and by that we will get the result of the values of these variables x, y, z, which are the solutions of the system of equations. Okay friends, now we can prove this one also. Let's see how to get the solution x out of this equation Ax is equal to B. Now first of all, for that let's take the equation Ax is equal to B. Now since A, the body matrix A is a non-singular matrix as given in the information in the theorem, so if A is non-singular matrix, then inverse matrix also exists. We know it before by the theorems. Now if A inverse exists, then we can multiply the A inverse from the right side of both sides of the equation Ax is equal to B. We are multiplying A inverse from the right side on both sides of the equations. Now as the product of matrices is associative, now we can remove this bracket from Ax and we can put it here on A inverse A. Now when A inverse A is multiplied together, they result in the identity matrix I, and when identity matrix is multiplied with X, it becomes X. So the solution matrix X, now its value is A inverse into B. Now we know the value of A inverse, it is adjoint of A by determinant of A. So in this way we got the value that X is equals to A inverse into B, or you can write adjoint of A into B by determinant of A, but provided its determinant should not be 0, it should be non-singular, then only it is possible. Okay friends, now let's move on for the second part, that how many different type of solutions are there in this system and whether the system solution exists or not. By that they have also some name. Now the first important term that we are going to learn is trivial solution. Now what is trivial solution? A solution where all the values of the variables are 0 at a time. That type of solution is called trivial solution. If here the values of the variables are x, y and z, if the values of the x, y, z will be all together is equals to 0, then that type of solution is called trivial solution, and it is called non-trivial when the solution of the or the values of the variables are not 0 at a time. At a time they are not all 0, some of them may be 0 at a time, but not all of them are 0 at a time. This type of solution is called non-trivial solutions. Okay. Now consistent system, a system of equations which has a solution is called consistent system. If a system of equation has a proper solution, then it is called consistent system, and if a system does not have any solution, proper solution, then it is called inconsistent system. Okay friends, these names that we have learned are going to help us in the further studies of the matrix method in solving system of equations. Now as we know that the solution of the system of equation depends on the product of the adjoint of A with B and the determinant of A. So in that way, taking them together, we can categorize the whole system of solutions or the method of solutions or the categories of solution in 4 different categories, and I have written them here for your understanding. Now if the determinant of A is not equals to 0 and the product of the adjoint of A with B is not also equals to 0 matrix, then what happens in this case? In this case the system is consistent. You know, system of consistent means a solution will be here, you will get a solution here, solution exists, and what is the nature of that solution? It will be unique solution. Unique solution means you will get only one set of solutions, only one single values of x, y and z and whatever the variables you are using in the system. You will not get repeated answers. The second case says that if the determinant of A is not equals to 0, but the product of the adjoint of A with B is a 0 matrix, then also the system is consistent, but the solution will be trivial solutions. Trivial solution means the value of all the variables will be 0 at a time. The third case says if the determinant of the body matrix A is 0 and the product of the adjoint of A with B is not a 0 matrix, then in this case the system is inconsistent. Inconsistent means here you will get no solution, the nature is no solution. So this is the one and only one case where the system will be inconsistent and there will be no solution. In all the other 3 cases you will get some solutions, but here you will not get solution. And what is that case? If the determinant of A is 0 but the product of the adjoint of A with B is not a 0 matrix, in this case only you will get inconsistent system. Now the 4 categories of first category says that if the determinant of A is 0 and also the product of the adjoint A with B is also 0 matrix, then also the system is consistent. That means here also you will get a solution. Beside the determinant of A is 0, then also you will get a solution here. The system is consistent, but it will be infinitely many solutions. That means you will get uncountable number of or set of solutions here in this case. Okay friends, now let us move on to the example where we will solve one of the systems of equation by matrix method. So the problem I have taken that I have to solve 3 linear equations, a system of linear equations containing 3 variables x, y, z by matrix method. Now before taking the equations for my calculations, first of all I have to check whether the variables are arranged in the proper sequence or not. That means the variables x, y, z, those are present in the equations should be in their proper form in all the 3 equations. You see the first variable is x, the second variable is y and the third variable is z, and they are in the proper order. So no need to worry, they are already in the form. Now let us take this system in the matrix form as A into x is equals to B matrix, where the A will be, A matrix is the body matrix which contains the coefficients of x, y, z taken in the proper order, you can see, and B matrix is the right side constant matrix, column matrix 8, 8, 6. Okay. and the x is the variable column matrix x, y, z. Now, we can write this system as equals to a into x is equals to b, a x is equals to b, as you can see. Now, before moving for the solution part, we know that first of all we have to find the determinant of the body matrix. So, the body matrix is A and its determinant, as I have calculated, it is coming -2. So, whether it is positive or negative does not matter, the matter is it is not equals to 0, and if the determinant of the body matrix is not equals to 0, then we know that the matrix is a non-singular matrix. If the matrix is a non-singular matrix, then the system is consistent. That means, here we are going to get a solution, definitely we are going to get a solutions. That means, we can move for the solution part. Now, the second part is the adjoint of A, and to get the adjoint of A, we know we have to find out the cofactors of the body matrix A. So, we will get the cofactors of all the elements of the body matrix A, and we will replace each and every element by their own cofactors, which will call, by that we will get a matrix. See, I have calculated the cofactors of each and every element of the matrix A, as we know before. After calculating, I have replaced all the elements by their cofactors in the same matrix, and I am getting the cofactor matrix of A. I already told you in my previous video that C of A I am writing as the cofactor matrix obtained from the matrix A. So, C of A is not that C is multiplied with A, it is a symbol I am using, that C of A represents the cofactor matrix obtained after the matrix A, that is this one. Now, you can put the values of these cofactors. Now, adjoint of A is nothing but the transpose of the cofactor matrix. So, make the rows to their respective columns. First row will become first column, second row becomes second column, and third row become third column. In that way, we are getting the adjoint of A. Now, after getting the adjoint of A, the next thing is we have to multiply the adjoint of A with B without changing their order or their sequence. We will first put adjoint of A, in the second place we will put B and we will multiply them. So, after multiplying in the row by column process, which is the only one process for the product of the elements of the two matrices, row by column process, we are obtaining a column matrix here, which is -6, -2, -2. So, as all the elements here in this column matrix are not 0 at a time, so it is not a 0 matrix. Now, if the adjoint of A multiplied with B does not result in the 0 matrix, then we can say that the system has a unique solution. It has a unique solution. You can see that conditions in that category box I have given. Now we are confirmed that we are going to get a unique solutions. Now, let us go for the solution now. The solution matrix X is equals to 1 by determinant of A. Determinant of A is a number, it is -2, and adjoint of A multiplied with B we have already obtained, is a column matrix. So, write the column matrix, and with that you multiply 1 by -2. You can take the minus to the numerator, it will be -1 by 2, and then you can multiply it with this matrix. That means, with all the elements of this matrix. So, after multiplying, you will get the values as 3, 1 and 1. When -1 by 2 will be multiplied with all the elements, the result will be 3, 1 and 1. Now, you can now write the X matrix in its full form, that is a column matrix of X, Y, Z. Now, you see we are getting through matrices of same order. So, by equality of matrices, respective elements will be equal, that means X value is equals to 3, Y will be 1 and Z will be 1. So, in that way we are getting the solutions or getting the values of the variables used in these systems. Now, this is the first category of the solutions. Now, you can take different other examples also, and you can check yourself and verify yourself the how it is working in all the other three cases. So, friends, I think you are little bit clear about the matrix method to find the solution of a system of linear equations. Thank you very much for watching this video.